in this problem, we're being asked to take the derivative of the quotient x to the power of 4 plus 3x squared all over x squared. Now, we do actually have a derivative rule to handle quotients. That's the quotient rule. We haven't looked at that yet, but what we're going to go ahead and do instead is try and rewrite this so that we could actually apply the power rule, the rule that we do know. So how are we going to rewrite this so we can apply the power rule? Well, what I want to go ahead and do is I want to go ahead and split each of these numerator terms up so that I can have a fraction separate from one another. So what do I mean by that? Let's go ahead and rewrite this out here. This would give us the derivative of, once I split the numerator up into two separate fractions, I get x to the power of 4 over x squared, and then I get 3x squared over x squared. Now, still not in the exact form I want, but what I'll go ahead and do now is just simplify using my exponent property. So I know here x4 over x squared, that should become x squared. We can either notice if you get rid of 2 of these 4, you get 2 left over, or we can apply the exponent property where when you divide same base, you subtract the exponent, right? So I would divide by x squared by subtracting 4 or subtracting 2 from 4 and getting x squared left over. Doing the same thing here, x squared and x squared in the numerator and denominator would cancel out, or you can apply the same property, and so I get 3. Now here I can go ahead and take my derivative because each of these is in the form of what we would want for a power rule or some other form, right? So derivative of constant, I know that, and then this fits our power rule form. So let's go ahead and take the derivative here. X squared becomes 2x, right? Subtract 1 and becomes power 1. And the derivative of a constant we know is 0, so I don't even have to write plus 0. I can just leave that as is. Therefore, the derivative of this big mess over here, this quotient, is just equal to 2x.